this tutorial, I'll not check the previous. Sometimes I'll just remind you guys, it's ready for your lessons. I saw some kids did not come to the class for a long time. So actually, last week, the chair of Tripoli just reminded every faculty again. I try to remind our students to come to the lecture and tutorial. And yeah, for me, I trust you guys. I think you guys are smart. I enough to actually, for this course, I think I'm confident about this. So I can teach you guys the most course of for your friends, I don't know, maybe some members just in early class and disappeared, okay? So I assume I don't know, but actually I know. So just try to remind your classmates, okay? Sometimes we come for some kind of a lecture events like last week, okay? It's actually not very easy, okay? So if only like we just take the video lectures, I guess we have a lot of concerns, questions. Okay? So this is a time to come to lecture with the tutorial, right? And to actually communicate with me. And I really welcome you guys to come to my office. Okay? So my time is given to you guys. If you have any questions regarding the lecture notes or problems, okay? Just feel free to send me an email. And I'll just make some time for you, I can just personally talk to you to address the concerns about the questions. But all in all, okay, like I informed you, the students from my tutorial session, successfully passed the final exam, okay, and also has a good score. Okay. So now, according to the syllabus. Now we're which week? Week 9, okay, already. So last week we just did ICA 4, and then today we'll have tutorial A. Then next week we'll have ICA 5, and then following we'll have quiz 2, okay. And after quiz 2, we're almost reaching to the end of the semester, okay. That's fast, right? That's fast. Okay, yeah, today week 9. Alright, so last week we just got one problem, not so kind of repetition. So today we just go through it because we don't have essay today, so we have sufficient time. And also week 8, the lecture contents are not difficult. Okay? So all applications are difficult. Alright. So last time we just talked about discrete Fourier transform, right? Let's just quickly recap. So last week we talked about discrete Fourier transform and also fatigue, right? The most difficult part is fatigue, fast Fourier transform. Okay. And for discrete Fourier transform, actually, because it's a discrete time domain to discrete frequency domain, you just need to remember actually there's kind of similarities and analogy to different formats. For example, like DFT and DTFT. Okay, what's the similarity here? And only difference here, like for this basis here. Okay, complex basis. Here is continuous, but here is discrete. Okay, so we discrete within beams. Okay, so here k is actually the index, and for DFT, and we transform from discrete time domain to discrete frequency domain. Okay. For DTFT, it's from discrete time domain to continuous frequency domain. Okay, that's the only difference. How about Z transform? as we know, like Z transform is a very general expression. So it's more generalized than DTFT. So what's the similarity between DFT and Z transform? So Z here is also a basis. It's with a circle R, E, that's G. So R is the radius, right, of a circle. And if you consider about it, so actually here is also the discretized version, right? Discrete version, with the Z transform, and when Z equals to this value, so X, in DFT exactly approaches to X. And some examples, showing like you study here. I guess maybe in the final exam there will be some kind of problems occurring, regarding and how to get the key and n, right? Let's say you have to n is 500, right? And you have 500 points, and the sampling frequency is 10 or 20, and then you need to find t, right? You're given the original frequency. And what is that's the t, right? And so it's very easy to calculate. Just find this equation, and you get the corresponding number here. Okay. And maybe another question is like, if we know k, the index k, and to calculate how many numbers, okay, the n here, just same way. And another thing is about discrete, matrix representation, right? For DFT, and for all this can be represented with a matrix D with a dimension n. Right? So x key actually can be expressed as dn multiplied by x. So how to calculate the inverse? Okay. So if you know like a discrete frequency and how to get the input time domain for the signal, okay, just apply the matrix, the inverse, okay. Here the dn, this is what's this? This is conjugate matrix, okay. This conjugate matrix. And then some properties, linearity, and also something. So here we also need to mention, last time, there's a question about circular shift. Okay, circular shift is like there's some patterns. Let's say here have 6 numbers, so n equals to 6, and just every time we repeat the patterns. And for circular, let's say n minus 2, like means like you rotate twice. And another one is about circular convolution. This is often applied to this kind of frequency input, right? 2 signals and with circular convolution, and then 3 steps. First, flip, right? First flip, similar to the traditional convolution, right? And then shift to the whole sequence to match, okay? Another signal, and then next to apply to calculate the result of the circular convolution and rotate. Okay, let's say move this one to here, and this one to here, and this one to here, this one here. Okay, you get y0, and then for y1 you just rotate once, and rotate again, right? You get this one to here, and this one to here, and this one to here, this here. Okay, so then very easy, right? All right, so the most difficult part is actually f of t. Okay? So why do we consider f of t? Because it's faster. Okay. So why the DFT is slow? So if we consider about the complexity, right, of the computation, so we know like it's n squared, the multiplications and n squared additions. So this is quite computationally heavy. So to reduce the computation, so we have an idea, to split the D, right, the matrix to be half. Okay, D with n divided by 2 and D with n divided by 2. So in this case, we have n squared divided by 2 multiplication conditions. Regarding this, there are 2 kinds of f of t. The first is dit, okay, decimation in time, okay? So the idea here is like we, based on the input xn, we first split into even numbers and odd numbers, okay? Given the index n. N is actually, here is dependent on the index, okay? Let's say, we have total 8, index. So Gn is like x2 and we couldn't get an even index, okay? And for 2n plus 1, we only get an odd, right? Odd index. So in this case, we get, split the signal, okay? Input to the Gn and Hn. So with a simple deduction, you can get the frequency, right? Xk equals to Gk, and added by Wn. Wn is a kind of weight, right? Weight with this kind of basis. E minus G2 pi k divided by n, okay? And with Hk. Okay, this is a very simple form. So in this regard, like when it's even and all indicates index. Okay, we get G and Hn, and multiplied by the Dn divided by 2, right? The two matrices. And then next is the process. Last time I mentioned, for DIT, like, so how to understand this? We consider about this kind of idea, right? So we just consider it's a binary tree somehow. We have total like 8, and then first 4 by 4, and then this 4 can be divided by 2 by 2, 2 and 2, right? And this was 2 and 2. So for DIT, and we often start from the bottom to up, okay? Bottom to up. This is a DIT process, okay? So this is a way I propose to actually, for you to easily understand, okay? But for FIT, it's a reverse way, okay? This side is FIT, okay? So now let's take this as an example, okay? So G and X and Hn are actually split the inputs, right? Here we got X2, X0, 2, 4, 6, and then it's 1, 3, 5, 7, right? Gn is even index and Hn is odd index. So step by step, we first start from n divided by 4, right? 8 points here is n divided by 4, n divided by 2, n divided by 1. So you can just consider about this, For DIT, you first start from n divided by 4 is 2 point, okay? 2 point DFT, and then next 4 point DFT, and then next 8 points, okay? So this is the process of DIT. Okay, so this is a way, showing the 2 point DFT. Here is the butterfly, okay? Butterfly multiplication. Okay? Quite straightforward, okay? So we start from this side, first divide. And in this case, we have x0, x4, right? And another one is x2, x6, right? And this side we have x, right? x1, x5. This side we have x3, x7, right? So this is exactly from bottom. Okay? Then 2 points, and with point, and then after this you have 4 points. Okay? After 4 points, you have finally 8 points. Okay? This is the way to understand the DIT. Okay? So one thing you need to mention is for W and this kind of the result is always delta minus 2. Okay? Minus 2 is minus 1. So what y equals to minus 1? often consider these phases. Okay? Plugging key here is n divided by 2. Okay? Right? So if you calculate this, okay, minus 1. Okay? So replace here. Replace all this, okay, minus 1, minus 1, minus 1 goes here. Okay? Because here is W is actually the weight is W2 0 and W2 2. Okay? Here that is. Okay, FIT DF. Okay, DF is actually what do we do the reverse manner. Okay? So you often start from this. And what we do is like instead of discretizing, okay, the input to be with all canons or even canons, because like for DIT we do is like only for index, okay. Index is 2k, 2k plus 1. But here for XN, what we do is like we split this to be with even inputs and all inputs, okay. So X0 here always stores, is a frequency, okay, instead of the index. X0 is about the frequency, because here is about frequency, okay? Let's say, okay, DIT here always stores n, right? To n or something like this. 0, okay? Or, okay, it's all often about index in the time domain. But for frequency, for DIF here, it's about key. Okay, key is for frequency. So that's why here we often consider about 2k or 2k plus 1. Okay, it's about frequency. Okay, so the output here is actually the reverse. Output often get the frequency. Okay, let's see here, x0, x4 is one pair. Okay, this is the output because it's a reverse. And then or x1 or x5 is for x2. Okay, some example of this. You understand? Now let's go with the question. Okay, so you can quickly understand that. Okay, so last time we have such a kind of problem. First, the 4-point DFT, right? The input xn is 2, 3, minus 3, minus 2. And we're using the matrix form, okay? So the first question is matrix form. So in that case, we need to calculate D4, right? And then equals to right? This is about D. Okay, this is about the matrix D with the dimension 4. So you can get a quick calculation, right? Of each weight. We call the weight here. Okay. How much? 1 minus 3. 1 G, right? 1 minus 1. 1 minus 1. Okay. 1 G minus 1 minus 3. Right? Right? So let's say like W4 1 is E minus 2 pi, right? And here K is 1, okay? Divided by 4. Okay? So you get how much? It's pi divided by 2, right? So it's E G minus G. So you just use it with the cosine sign, right? Cosine it's minus G, right? Sine. Okay? So then equals to minus G. Okay? So similarly for other weights, all the same. Questions? It's very basic. Okay? Understand that, right? Why all these numbers? You got it, right? Yes. Okay? So for each weight, you just need to calculate, plug in here the key. Let's say here P equals to 6, right? 6 is replaced with 6, right? And then you'll get, 3 pi, right? Because this one can be replaced by 3 pi, right? And here, sine 3 pi. Okay? And 3 pi equals to pi plus 2 pi, because 2 pi is a phase, right? So you get cosine pi, right? And g sine pi, right? So how much? Minus 1, right? Right? So here is minus 1. Okay? Quite easy, right? So with this d here, and then next we calculate xk, right? So xn equals 2, 3, minus 3, minus 2, right? So, and you can write down, the output. Okay, so let's just do it. Here's 1 plus 2 plus a1 plus 1, 3 plus minus 3 times 1, right? Plus minus 2 times 1, right? And this side is 3 times 1 plus minus g times 3 plus 1 times 3 plus here. And then this side is 1 plus 2 minus 1 times 3 plus 1 times 1 minus 3 times 1 plus minus 2 1 times. Okay? And this side is 2 plus is minus 1 minus 3, right? And then last time is minus g is minus 2. Okay? Right? So plugging all is with matrix multiplication, and finally you'll get the 0, right? 0 this side. How much? 5? Oh, sorry, here is 2, right? It's minus 2. Okay? Right? Oh, here's 2. So here's 5, right? Minus 5g, right? And this line is 0, right? And this line 5 plus 5g, right? Five. Which one? Which one? Minus 2. It's minus g. Minus g. There's 2g and there's 3g. Okay. Just make a calculation. What's the result? What's the result? Okay. So here's minus 2, right? And this one? Minus 2?
Yeah.
Okay, it's minus 2. Right? Let's say minus 1, right? And then here you have 2, right? 4 and okay, it's minus 2. Okay. So the final output is 5 minus 5g and 6 minus 2. Okay, this is about xk, right? Then next, we need to consider about 5-point decimation DIT. Okay. So how do it? So here's input. Okay, here's 3 minus 3, 2. So based on the definition here, we first go with Gn equals to x 2n, right? X 2k. Let's see. And Hn equals to x 2k plus 1. Right? We get even index and odd index. Okay? So then Jn is what? Is x 0 and x2, right? Okay? Hn will be x1, x3, right? So just if we list here Jn will be 2 minus 3, right? And Hn is 3 minus, here's the minus 2, here's minus 2, right? Okay, this is Hn, okay? This is Jn, okay? Right? This is first. Split with index, okay? The n. So you get, here's Jn. This is just like a exchange, okay? Okay, you get even and odd, okay? Hn is odd and Jn is even, okay? So now, you got it, right? No problem. If you have a problem, just let me know, okay? This is very, very critical, okay? First step, just repeat, okay? The input here, 2, 3, minus 3, minus 2. And you first split with Gn and Hn. Gn is the even index and Hn is odd index. So here we have, this is the index from 0, 1, 2, 3, right? Given xn, 0, 1, 2, 3. So you get even index here, x0 and x2. So you get 2 and minus 3 for Gn. Okay? And then Hn is about x1, x3. So you get 3 and minus 2 for Hn. Okay? No problem, right? Alright, so with this, now let's do, according to the idea here, as I mentioned, we have this kind of idea, okay? Right? So similarly for 4, you can only do this, right? This for 8 points. For 4 points, you can only do like 2 by 2, right? 2 and 2. So here, you first start from 2 and 2, right? So go with butterfly, right? So here is minus 1. Okay, just a little bit. Okay. So here should be W2, 0. Okay? And similar to here, just do like this way and this way, right? We have 2 nodes here. Okay. And here's minus 1. It's W2, right? 2, 0. Alright, so now let's calculate. Here we have the output. What is output is this line? Is 2. W is 1, okay? Plus minus 3, right? This side. Okay? And how about this side? It's 2, because here's minus 1, okay? So minus, here's minus 3, right? Minus 3, right? And how about this side? 3 plus minus 2, right? And how about here? It's 3 minus 2, right? All right, you got it? Questions? Very, very important. No questions? You guys cannot see it, right? Okay. So this side we have, now we have, okay, here is about -1, right? Here is about 5, and here's what? 1, right? And here's 5. Okay? So we all have, let's just replace. Here is, how much? -1, right? 5, 1, 5, right? Okay. Now we have done with 2 points. Now about 4 points. Okay? 4 points, how to do it? And then first, okay? Right, butterfly, again, butterfly. Right? Right? So here we have W4 0, W4 1, right? Okay, all right. So what is the value of W41? -G, right? -G. So 5 times -G will be here, up to here we'll have -5G, right? Right? Up to here, because this one is -G, okay? So 5 multiplied by -G is -5G, okay? And then here's 1, here's 5, here's -1. So let's just make a, calculation again. It's -1 plus 1 multiplied by W4 0 is 1, right? Okay, you get 0, okay? And how about here? This one? 5, right? -5G, okay? And how about here? -2, -1? How much?
They need a -1 somewhere.
Hmm?
-1.
Here? It's -1, and here? It's 1, right? 1. Right? You got it? Okay? And here's 5 minus G, okay? So let's take a look. Here's 0, and here's, so you'll get 0, 5 minus 5G, -2, 5 plus 5G. Okay, exactly it's the same, right? Right? Quite easy, right? If you just understand the bottom to top. Okay. Let's just do it again. Okay. So let's first finish the third question. So how many multiplications and additions required in part 1? Part 1 is treated in DFT, right? And how many multiplications? Because I listed here. Okay, let's count. How many multiplications? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? 14, 15, up to 16. Okay. You total have 16 times the multiplications. How about additions? 16. 1, 2, 3, 5, 6.
Or 12.
No, 4, 2, 4, 5, 6. Okay. Total is about 12, right? Okay. Multiplications 16. How about additions? Additions how much? Yeah. Yeah, 12, yeah. So okay. Multiplications 16 and additions 12. Okay. But if you try to recall, okay, in the lecture note, it's written as n squared, okay? N squared for multiplications and for additions. So I mentioned last lecture, this first one n is very large, okay? But if, in this case n equals to 4, okay? We cannot just say like this, especially for additions. It's n times n minus 1, okay? That's 3 times, 4 times 3 is about 12. Questions? Okay, now let's count DIT. How many multiplications?
One.
Why is one multiplication? Let's first enumerate this. How many? Remember you have this, right? No, right? Here because it's 4, okay? It's about this, right? So it's what? 4 divided by 2 log 2, 4, right? You will have 2 times 2, 4, okay? And then how many additions? How many additions?
4 times 2.
You remember, here we have ones, right? One addition. And what's the equation to calculate? N log 2n, right? So it's 4 times 2, 8. Exactly here, we have 4 here and 4. Okay, total 8. And for multiplications, here we have 2 and here 2. But because here we had made another change, like for those multiplied by -1 or +1, we don't count it as a multiplication. Okay, so in that case, only this one is counted as multiplication. Okay, that's why we have 1. Okay, but this is somehow misleading. Okay, I don't really encourage you guys to do this way because more in a conservative way, and this should be multiplication. Even 1 multiplied by 1, okay, still multiplication. Okay, so that means that we have to really have like 4 multiplications and 8 additions. But if some of you you check the answer, but it's about 1. The 1 is here. We only count 5 multiplied by -3. Okay, but this is actually not very good because sometimes if you just do like this way, kind of misleading you. Okay? Why is just 1? You understand what's wrong? Okay. Okay, so these guys cannot say calculation process. Okay? So let's just do it again. You got this one, right? So easy, right? Okay, let's just do it this side. So we have kind of input 2, 3, -3, 2, right? So based on the definition, like the xn, we first get gn and hn, right? Gn equals to x to, let's see, m, okay? And hn equals to 2m plus 1. That means this is we get even index, and this is the odd index, right? So because the index starts from 0, 1, 2, 3, right? So for what's gn? Gn we only get x0 and x2, right? Right? This is about gn. It's an index. This one and this one. Okay? And hn we have x1 and x3. Okay? So now for in this case we'll get 2 minus 3 for gn, right? Got it? Questions? Okay? So for hn here we have how much? Oh, this is minus 2. Minus 2. So we get 3 minus 2, right? For gn, this is gn, okay? And this hn, okay? This is gn. Okay? Got it, right? So now we have 2 minus 3, 3 minus 2. Okay. After change. Here's this gn, this is hn. Okay? So now based on what I talked before, okay? So for 8 points we have let's see, 8 points we will have divided by 4 by 4, and then 2 by 2, and then 2 by 2, right? And then bottom to up. So the following is similar manner. Right? So for 4 points, and we can only divide by 2 and 2, right? We cannot divide by more, because this doesn't work. Okay? So we have our bottom to up, right? So that means we first do butterfly. Okay, here this way and this way, right? And here this should be -1, and here is double 2, 0. Okay. Similarly for here's for Gn, Hn, right? Hn also the similar way. Okay. And it's -1, that's double 2, 0. Okay. All right. So now we can just calculate, okay? Is 2, and then plus -3, because this one will be 0 to 1, okay? So, and how about this side? This side is always 2 minus, because it limits is minus, okay? Minus is -3. Okay, and this side, 3 plus -1. Okay, this side, 3 minus, okay? Minus 3 minus -2. Right? Got it, right? Quite simple. Okay. Now we have here's -1, here's 5, here's -1, right? 1. 1 here is 5, okay? Well, let us rewrite, okay? We have -1, 5, okay? 5 and 1, 5. Okay? So we finished 2 and 2. Okay? Now to find 4 points. Again, butterfly. Okay? So you connect this manner. Okay? Connect this manner. Okay? This side Hn. Okay? Just get 4, 0, W, 4, 1. Okay? This is all -1. Okay? So just do it again. And here you get -1 plus 1, right? And then you get 0. And here's 5. And for this W, 4, 1, just go to -g. Okay? Okay? So that's why here, after here, you already get -5g. Okay? Here's one multiplication. Okay? Questions? No questions, right? Be sure to understand. Okay. So over here you get -5g. Okay, that's why just W41 is with -g. Okay. So here you got -5g, and then in this case you plus -5g. Okay. And then here you got -1, and here multiply -1. Okay. Right. Okay, so here in this side we got -5, -5g. Okay, right? Okay, so okay, it's 5g. All right. So finally we'll get 0 minus 5 minus 5g and -2, right? And then 5 plus 5g. This is all. Okay. This is all. So from 2 points and to 4 points. This is what we call from bottom to up. Okay. So if you understand the convention this way, I think it should be much easier for you. Right? Okay. So because here we only count -5 multiplied by g, so it is multiplication. Okay. In reality, actually, it's 4 multiplications. Okay. Questions? I assume you guys all understand this. Because it's the most difficult one. Okay? Questions? Do you understand, right? So here, this is the mirror, because this is only one exam. Here's the G and here's the H. Okay? So if you check, the answers here, actually, some of you might be misled, okay? So this is only the original exam. Okay? So once you get Gn here and Hn here, you shouldn't ignore accent here. Because if you keep these two, you will be kind of perplexed. Okay, you just feel like, wow, why these two? Okay, understand? Here, don't consider about this. Here's G and position. This will always make sense. Okay, so once you get G and definition, we should ignore this G and position. All right. Questions? No questions, right? No questions? We do today's tutorial. All right. Today's tutorial, I think, yeah, questions are very easy. Okay. Okay. So we're actually applying BTFT. Okay. Here, like first question, HEG omega equals to 0.5 added by 0.5 multiplied by cosine omega. So determine if the filter passes or stops the following frequencies. Okay. So I will try to go through the slide, the lecture notes, because we have no time tonight. So, but actually it's very easy because all the contents we have covered, in previous lectures. It's very BTFT. And then in this case, the first one is the radius, okay? Is omega equals to 0, okay? G omega equals to 0.5 plus 0.5 cosine omega, okay? When omega equals to 0, you just plug it, okay? Just plug in here, H E G omega equals to 0.5 plus 0.5 cosine 0, okay? Right? How much?
1.
It's about 1, right? Okay? Pass or field?
Pass.
So when the magnitude equals to 1, pass or field?
Pass.
Pass, right? So radius with 0 should pass, okay? Okay, then omega equals to pi. And similarly, that is 0.5 plus 0.5 cosine pi, okay? How much?
C.
0, right? Pass or stop or field. When the magnitude stop, okay? This is stop. Okay? Are you safe? Okay. Then the next question is just like a kind of a high school, okay? High school, math problems. Okay. You have a kind of A, B, C, right? A plus B, Z minus G, and C, Z minus Q. Okay? So Z, as we know, if we assume the radius equals to 1, right, it should be, okay? Right? So just plug in here A plus B E minus G omega plus C E G2 omega, right? Okay. So now when the frequency equals to 0, that means omega equals to 0, right? The frequency response is 10. Okay, that means just plug in, okay? A plus E, 0 is 1, right? Plus B plus C equals to 10. Questions? Am I right? Okay? And when frequency equals to pi divided by 2, okay? So we just plug in here, B, E minus G divided by 2, right? And plus C, E, okay? Right? Equals 2 minus 2 plus G2. Am I right? Okay. So what is E minus G pi divided by 2? Here's minus G, okay? minus q, okay? So how about this one? E minus g pi. How about, what's the value of this? What's the value of E minus g pi? Minus 1, right? This one equals to cosine pi e minus sine pi, okay? Right? Okay, cosine pi, this one should be equals to minus 1, okay? Cosine pi is minus 1, okay? So you'll get, here is minus 6, okay? So, obviously here, b minus bg equals to 2g, okay? So b equals to minus 2, okay? From this equation here, right? Because here it only has bg, right? So then a minus c equals to minus 2, right? From this equation here, okay? Questions? Okay, b equals to minus 2, and then a minus c equals to minus 2, okay? So here already, like, you have a plus c, okay? Because b is minus 2, right? So a plus c equals to 12, right? So a plus c equals to 12 and a minus c equals to minus 2. So what is a?
5.
A equals to 5, right? C?
7.
7, right? Easy, right? Questions? Did I ask it? Okay. So, two conditions, okay? When omega equals to 0, the summation is 10, okay? And when omega equals to pi divided by 2, the summation is minus 2 divided by 2j, okay? So give condition here. This is for condition 1 and this is condition 2, okay? There's two conditions. And from here you observe that, here is minus bg should be equal to 2g, okay? There's only this term, okay? So you know that b actually equals to minus 2. So, if you get this, so a minus c should equal to minus 2, okay? Minus 2, and here a plus b plus c equals to 10, so now a divided by c should equal to 12, okay? So given this is 1 and this is the family, this is 2, okay? This given, combine this equation 1 and equation 2, you get a equals to 5 and c equals to 7, okay? Finally, the form is actually b equals to minus 2, right? Minus 2 and a equals to 5. C minus 1 plus 7, z minus 2. Okay, this is the output. And next, find the frequency response at the frequency pi divided by 3. Okay, omega equals to 3. So you just plug in, okay? 5 plus minus 2 e to 7. Okay, just plug in. Okay, just plug in and you'll get, just try to combine, you'll get the final result. Okay. So in your calculation, you do not need to keep the something like a point. Okay, but just only keep So let's say cosine. Cosine pi divided by 3 is how much? How much? Right? So just keep that kind of numbers. Just combine and get back. Okay? Alright, so next one. Next question. Okay, H0, 0.5, H1, 0.8, H2, 0.5. And the rest of the coefficients are zeros. Okay? So first, define and simplify the magnitude response. So we know like H then equals to, so 0.5, 0.8, 0.5. Okay? Because others are all zero. So if you represent it with, we'll first simplify. Okay? Right? We can do this way. Okay? And then try to plug in here. And you first need to simplify. Okay? How do you? Factorize. You need to factorize. Okay. So factorize, right? Because here we don't have E minus J omega is always a basis. Okay? The basis. So we just extract the minus J omega's basis out. Okay? So here it should be 0.5 E J omega, right? Plus 0.8, right? And then plus E minus J omega. Okay? Okay? And then 0.5, we just combine this both. Okay? G omega plus E minus G omega. Okay? Plus 0.8. Right? And then these two, if we combine and just cosine omega, right? Because E G omega added by G E minus G omega is cosine omega. Okay? I choose cosine omega. Actually, multiplied by 0.5 should be cosine omega. Okay? Right? Questions? Okay. So this is output. Okay? And if you get the magnitude, okay? So it should be, so E minus G omega, what's the magnitude?
1.
So 1, right? So in this case, it's all cosine. So why we put absolute here? Because cosine omega added by 0.8 can be minus number, so that's why I put absolute here. Okay? Because magnitude is always positive. Okay? And next, maximum value. So what's the range of cosine omega? Right? Cosine omega is always within the range of -1 to 1. Okay? Then cosine omega added by 0.8. What's the range? Minus. Okay, 1.8, right? But here, if we just put the absolute, okay, should be larger than 0. Okay. Okay. Right. So because this is close to the magnitude, it's finally should be less than 1.8, right? So the magnitude maximum value is 1.8. Sorry? You understand, right? All right. So next. Questions? This time? No questions, right? It's easy, right? Still trying to cut? This one is easy, right? So next one. next one. For this, Xn, okay, there are two linear systems. So what's the property of two linear systems? The addition of two linear systems. Because here, this one is LTI, okay? Linear time invariant system, environment, okay? LTI system. So Xn here and this is addition. So what is the response here? It's sigma, okay? It's impulsive, okay? So in this case, system is always here, okay? This side is sigma n. And this side we have h. Okay? So the dTft of sigma, okay? Let's see here, you have x, okay? For impulsive response, it goes to 1, okay? So that's why here, actually it's impulsive, okay? So it's impulsive, and here we have h. So for this one, because of this addition, right? Addition. So for two linear system, addition of two linear system actually follows, a system for each, right? For each. So it's just for its frequency and response should be the addition both. Okay? So let's see. For H LP, okay, so this one. It has a condition and it's a cutoff, okay? And when frequency equals to pi divided by 4, it's a cutoff, right? What should be that? Omega how much here? It's a low pass filter with a cutoff. It's 0, right? And then others. Okay, it's 1. Okay? And how about here? This one? This side for Xn.
It's 1.
How about this side?
1.
1? How about this side? Xn here. So this is always 1, right? It's always 1 for any condition, okay? And here, because we have a minus, right? So originally here is 0, and when omega goes to pi divided by 4, right? And then how about minus? Just take reverse, okay? So in this case, it will be minus, right? 0, right? Because like originally, it's like this, right? And then because it's minus, here you have minus sign here. So we just change it, right? Okay, so now it's because a linear system, right? So the output Yn equals to Xn minus, right, H. Right? So it follows a linear system. Okay? So then, how much we get? How much we get? Understand? Okay, so originally this one, because of the low cost filter, okay? It's a low cost filter, and with a cut off frequency, right? It's high to level 4. So that means omega, the absolute less than level 4, okay? In that case, it's -1. This is 0, okay? But because here is a minus sign, then we just do the reverse. So in this case, the omega of the absolute maximum formula is -1, and that other is 0, okay? And then here, because it's a linear system, so actually we will get this kind of output, okay? So let's just combine both, okay? So if we just combine both, we finally get what? What's output? Omega then within this range, less than what's here? It's a linear system. 0, right? That's how much?
1.
Okay. So then you just plot, okay? So -4, 8, whatever. Okay. Then it should be like this, right? What's this? It's a low pass or high pass or band pass or band stop. It's a high pass, right? Okay. Because the signal between minus pi divided by 4 to pi divided by 4 are 0. Okay. So these frequencies are stopped. Okay. These frequencies are in the past. It's a high pass. Understand? So in this case, we need to actually recap. Okay. Recap to let you know. Let you know is here. Probably need to just go back to there's 4 types of signal, okay, in the filters. 4 types of filters, so this one is high pass, okay? So this range are yours, as it is called. Band stop is, I think, more than band, but this one, in this case, you can just go back to the actual. If you just, direction. Today's no triggers. Yeah, just go back to directional. There will be 4 types of either filters. This one is low pass, okay? This one is high pass, so exactly this one. Okay, this is not high pass. So within omega c, okay? So omega 1 is less than omega c. So all this frequency is 0. That means that it is a stop. Okay. Others will be 1. There's 1 in case pass. As you know, when k equals to 1 means a pass. Okay. K equals to 0 means a stop. Alright. You got it? So this is high pass. Okay. High pass filter. So last one, this is for a kind of proof, okay? So this is a question about group delay and time delay. Time delay, if you just recap the lecture notes, time delay is what? It's a phase, right? Okay. Then divided by omega, okay? Minus. Okay, and then how a group means that it's a differentiation, right? Right? This one for time delay, this for group delay. Okay? So now let's just try to prove it. So for H, E, G, omega, okay? Because there's amplitude. Let's assume the amplitude is a function of omega, right? And then for G, omega here, let's use G, okay? Also kind of with a variable with omega, okay? So first, let's plug in this. Differentiation of d, h, e, j omega divided by d omega, okay? So then it should be, recap your calculus knowledge, okay? Then it's differentiation, right? And then in the meantime for this one, right? A, E, G, E omega, right? Tan G differentiation, right? Calculus knowledge, okay? Because there are two variables, two independent variables, okay? Dependent variables, A and B, okay? So if you calculate, if you do with the calculus, right? You'll get this. And then now let's divide it by h, okay? H equals to this. Then plus A omega E G okay. So it's divided by right? And then here will be right? Then this one is cancelled, right? This one is cancelled, and in this case, and this one is cancelled, right? Okay, we'll get us G E right? Oh no, only this, right? Right? Then this is remember because this is a consumption. Okay? Look at G, right? So, what is the real part of this complex number? What is the real part? Yeah, because here also we have another G. Okay, we need to multiply this G. Yeah, then multiply this G here. Okay, so we'll get A. G and G plus G, right? It's called minus, right? Minus, right? G and G will be minus, right? Okay. So what is the real part?
B.
Minus B, right? That will be yeah. So if we just consider about time delay, okay? Time delay, let's see here. What is the alpha? Time delay? Time delay here exactly, right? Exactly, because the phase is actually B omega, right? Right. So finally, you will actually get, all of this. The real part is actually minus B. Okay. Okay. Exactly. Even for this case, even for group delay, for this, okay, time delay is B omega, okay? And then for group delay, it's B minus, okay? So these two are different, okay? Time delay and frequency domain, a group delay are kind of different in this case, okay? So the proof actually shows through this kind of proof, we know that it's exactly group delay, okay? So the real part of this process is actually group delay, okay? The process of demonstrating group delay, okay? Questions? Not very difficult, right? Not very difficult, right? Very difficult? Okay, so let's just recap, okay? Assume, because for kind of h, e.g. omega, it can be expressed as, here we have magnitude, right? Magnitude. This is magnitude, this is phase. Both with a variable of omega here, okay? Depending on omega. So we just plug in here. First take derivative, and then you multiply the g. So you'll get this kind of complex, okay? In expression. And if you take the real part, and you'll get this minus this one, okay? This is about the opposite. And then let's consider about group delay, okay? So if you go back to your original, so the group delay is actually minus the partial derivative, okay? The derivative with the phase, right? Because the phase is actually omega, so if you take the derivative, it's exactly, right? So this actually, this proof actually shows equals to group delay, okay? But for time delay, it's different, okay? It's d omega divided by a omega. All right, why here is different? So in what kind of condition time delay equals to group delay? If you recap your lecture, in what condition? Okay. In what kind of condition? So you can go back to your lecture now. So there's a clear example showing when the slides to here. It's a linear, okay, phase response. In this case, in general, the group delay equals to time delay for filters with linear phase response, okay? If it's a linear phase response, group delay equals to time delay, okay? So definitely for this one, it's not linear phase response, okay? That's why, time delay and it's not equal to group delay. If it's linear phase response, it should be. Just you can check this one. Yeah. Here's the condition, okay? Time delay equals to group delay. Only occurs for linear phase response. Okay. That means consider a kind of consider a kind of xn, right? Xn, and you just go through a kind of delay race. Okay? And in this case you'll get delay of, okay? This is kind of linear. That's why in this case group delay equals to time delay. All equals to that. Just displayed by time pole. Index. Okay, it's a linear response. Okay? Alright, all about today's questions. So I have to encourage you guys to recap the lecture notes. Actually today's are not difficult, okay? It's all application of DTFT. Okay, you just need to go back to DTFT, and there are 4 types of filters. So after learning this lecture, okay, you need to understand 4 types of filters: high pass, low pass. What else? Okay, so 4 types of filters, and then loop delay and time delay. Okay, because in next lecture we'll also use these technologies. Okay.